Today we are going to see about the structure of a power system, how the power will be generated and transmitted and as well as distributed to the consumer. The ultimate aim is the generated power is properly utilized by the consumer. In order to ensure that the generated power will be distributed to the consumer through the proper channel, that is called the structure of a power system. So it consists of various level of power will be the voltage will be transferred to the end consumer. So consider first one, the first is actually the structure in the power system. First one is generating station. Normally we have to generate the power in the voltage rating of 11 kV. Then basically why we have to generate only 11 kV? For optimal generation we need to generate only 11 kV. If it is beyond the 11 kV, the economy of the system is reduced, that is increased. Actually economy of the system is not good, so that's why we have to optimize the power generation at the voltage level of 11 kV. After that generated voltage 11 kV is stepped up to 132 kV by using primary transmission. That means that is called a primary transmission using actually power transformer. The 11 kV generated is converted or stepped up into 132 kV through primary transmission. The power will be transferred. Again reaches to the next level, secondary transmission. The 132 kV is stepped down to 33 kV using transformer. See, in this stage, the receiving station will carry out the stepping down and the secondary transmission process. After the end of the secondary transmission, the 33 kV is again stepped to 11 kV. Here the substation is placed and role in the primary distribution part. Then again the 11 kV is further stepped down to 400 volt or 440 volt 3-phase 4-wire system. Here we have to distribute the power to the consumer, that is called the secondary distribution. So the generated power is normally taking care of 11 kV the voltage level. The same 11 kV is distributed as a primary distribution. Here the HT consumer will be connected. Where the power requirement is high, for example by any industry, the power requirement is too high. For that case, that is called as HT consumer, high tension. The power will be tapped from the 11 kV. Then again for the domestic purpose, we are using in our houses we are using only 440 voltage if it is for 3-phase system, or otherwise we can use it for single phase 230 volt system. Actually the color, this is actual representation of the power transmission and distribution. The generating station is the primary step for the power generation. There the power will be generated, then stepped up using the generating transformer. Then again that power will be transmitted through the various level of voltage. It depends upon the rating of the power. The voltage rating will be decided based on the distance travel also. Then again the substation will be provided to step down the voltage. Then that will be distributed to the primary and secondary consumer. It depends upon the voltage rating. In terms of kV, we have to use it for the primary consumer. HT consumer, then we have to use it for the secondary consumer. So this is the secondary distribution system. How the structure of the secondary distribution? In that secondary distribution, the distributor, feeder and service main plays a vital role in the distribution system, especially in the secondary distribution part. So feeder connect with the different lines connected to the primary distribution. Then distributor connect to each and every feeder. Through the distributor, the service mains are connected. Where the service main is connected, the service main is the main which will be tapped from the distributor to the consumer. So each and every home will be connected through the service man from the distribution system. Why? What is the need of increasing the higher voltage level for the power transmission? We can generally, power is nothing but the VI cos phi. We can either increase the voltage or increase the current. Thereby we can able to transmit the actual amount of power generated will be distributed to the consumer. If it is we can able to generate the power, then we can either increase the voltage or increase the current. If it is increasing the current, we have to face it to two difficulty of the system, because of current will take the size of the conductor. That's why we have to go for the voltage. What are the benefit for increasing the voltage level? If we are increasing the voltage level, the power is also increased. What is the aim of this? The I square losses will be reduced, power losses will be reduced, corona losses will be reduced, conductor size will be reduced, so that the cost of the system is reduced and less voltage drop. So these are the major benefit while we have to increase the voltage level for the primary and secondary transmission. We have to transmit over a long distance. After that only the consumer able to get the power. If we are not increasing the voltage level, whatever we have generated, the generated power entirely will be wasted over the long transmission due to the I square loss, power loss and corona loss. That's why we need to increase the voltage level. That way we can able to get the power without our minimum loss. We have to see about how the same structure will be operated through the animation. This is the structure of power system. The power plant is the first point of the power system. Then again transformer is connected. Then the transmission will taken care by the steel towers that will be connected to the transformer. The each and every stage the transformer plays a vital role to increase or decrease the voltage level that will be connected to the distributor. Then again we can get it the power from the distribution for each and every home. So normally we have to generate the power in 11 kV, that is from the power generation. Then again the voltage will be increased, that is primary transmission. That voltage is depends upon the amount of power generation and length of the transmission that will be carried out through the transmission towers. Then again that 220 voltage again stepped down to 132 kV or 66 kV. That is called secondary transmission. There the receiving station will be connected to reduce the voltage level. For each and every level of voltage rating, the transformer plays a role. Then again 132 kV to 66 kV or 11 kV, that is called the primary distribution. Here we are using many substations to distribute the various voltage to the 11 kV system. Here we have to connect the HT consumers depends upon the need of power. Why? Because we have to connect the HT consumer, the power rating is high. That's why we have to connect the HT consumers in the distribution, primary distribution. Then again the 11 kV is converted into stepped down into 440 voltage, that is called the secondary distribution. Here the consumers, domestic consumers are connected. Thank you.